In this work, we present an algorithm for interactive character animation that includes real-time planning and parameterized motions. We first show the strength of our motion controller by comparing it to other controllers in the grasping control system. In a greedy controller, which selects motions based on the highest immediate reward, the reward function returns non-zero values only if the object is within a reachable distance. In this scenario, the character never becomes aware of the object since he is several time steps away. In this example, the initial motion segment is picked randomly while the subsequent motion segments are picked by the controller. To make comparisons, we use the same first motion segment for the next two controllers. With a planning controller, since the character has been trained, he knows how to walk towards the object. However, using non-parameterized motions, he can only step onto a discrete set of positions. This may not lead to a good position for grasping, so the character takes a detour to fulfill the task. Finally, with our parameterized motion controller, the character can make a near-optimal decision and grasps the object easily. In this experiment, we show that our motion controllers can make near-optimal decisions in real time. Initially, the reward function is defined to be independent of the effort needed for grasping, so the character can grasp it in any way. We change the reward function to be inversely proportional to the effort required for grasping, which asks the character to grasp the object in a way that is as easy as possible. This requires planning because the character needs to adjust his steps along the way. Finally, we change the reward function to be proportional to the effort required for grasping, which asks the character to grasp the object in a way that is as hard as possible. In this demo, we show that we can provide interactive control for users and that the character can respond automatically and instantaneously to user input. The reward function is defined as the sum of transition reward and state reward. The transition reward favors the motion segments which have smoother transitions, while the state reward favors those which help reach the goal. We adopt a scaling parameter to balance these two factors. In this video, we can see that if the distance between the character and the object is short, the character makes a sharp turn, since only a few steps are allowed to grasp the object. In the case that the distance is larger, the character tends to make several moderate turns. Since there is enough time and space for the character to change direction for a successful grasp, smoother turns result in higher rewards. This behavior can only be achieved by planning. We also build a guidance control system to test different controllers. The goal of the controller is to guide the characters through the gate in a specific direction without bumping into the doors or walls. The starting position and orientation of the characters are decided at runtime, and the location and orientation of the gate is also adjustable at runtime. With the greedy controller, the characters only notice the gate when they are in close proximity. Since they do not know how to plan to avoid obstacles, half of the characters bump into the gate. With parameterized motions, the range of possible motions for the next time step is increased so that the characters can better react to obstacles. However, without planning, 4 of the characters still collide with the gate. With our controller, the characters can plan their motions well in advance of the obstacle, allowing all characters to successfully enter the gate. In this and the previous example, we use the same starting positions and orientations generated for the greedy example to make the comparisons.